Okay, now this is what we're just going to keep literally doing for the rest of this time. Verifying identity, verifying identity. So whenever I'm looking at this, sometimes you work one side at a time. Sometimes you see the connection and you start working both sides. That's up to you. And that's what makes these awesome and sometimes frustrating at the same time. Tangent T minus cotangent T. You know what? I'm not going to use a T because we're using tangents and cotangents. Let's go back to X. Over sine X cosine X is equal to secant squared X minus cosecant squared X. Now let me tell you things that I'm seeing because I want you to think about this. This is my thought process. And so this is what I'm seeing. First thing I'm seeing is the fact that this is a monomial, a single term in this denominator. So this is a single rational expression, this is a single term, and this is not. So this tells me I'm going to hang on to this side, and I'm going to put these two together to get a common denominator. That's what this is saying to me. All right, so you can take this and split it up to each one of those, but this is a whole lot of crazy going down over here. This one, if I get my common denominator, then I should hopefully be able to see what's going down over here. All right, let's try it. I don't know. Remember, you cannot cross. And the other reason, whereas you're doing this, and sometimes I like to work two sides at the same time, there's no specific way to do these. That's the beauty and the detriment, right? So here, I'm not going to touch this side, but I need to keep rewriting it. Don't leave it up there at the top. You have to have that part in your face because that's your goal. My goal is to make both of these sides look the same. So I have to have both of these sides in my face all the time so that my very last thing, that proof at the end, is they're exactly the same. Okay? Now this is 1 over cosine squared, good, thanks, minus 1 over sine squared, because we know reciprocal identities. Then if I'm getting that common denominator, so I'm going to multiply this side by sine squared over sine squared and cosine squared over cosine squared. Basic algebra, right? These basic fraction skills. You're going to use your basic skills for the rest of your life in math. I mean, you're in this class, so you're planning on doing something with math, it'd be my assumption. Tangent x minus cotangent x over sine cosine equals sine squared x minus cosine squared x, and my common denominator is cosine squared x sine squared x. All right. Okay. So we're getting close, right? Now, for me, this is all in terms of sine and cosine. This is partially in terms of sine and cosine. So I'm going to hit this one. I'm going to come over here to this one and start working over here. That's what my head is telling me to do. That doesn't mean that's the only way to do this. And I may be sending us down a rat hole, right? We'll find out, our rabbit hole. You know, the old Alice in Wonderland scenario. So this would be sine over cosine minus cosine over sine. All over sine x cosine x. See now, and the reason why I was looking at this, because I'm like, this looks like it can set this up to maybe, I know I have to get this common denominator. When it goes down there, will get me something squared. And whenever I get this common term here, I know that this will be sine over cosine. Oops, sorry. Common denominator, sine over sine. And cosine over cosine. So it's starting to emerge. Do you see that? So I now have sine squared minus cosine squared over sine x cosine x. The whole thing is divided by sine x cosine x. This equals what I have. Do you see you cannot cancel this? I have a minus sign here. Because this is a minus sign, you cannot cancel those. That's not how that works. With this minus sign, you cannot touch those. All right, I just wanted to be clear about that. Sine squared x minus cosine squared x over, and yes, it does get annoying just having to rewrite the same thing over and over and over again, but you deal. And then multiply by the reciprocal. Do you see it just happened? When I multiply by this reciprocal, and there it is, right? There, my numerator is now exactly the same. And when I multiply that denominator, it is going to be the same. Because if I multiply this, sine times sine is sine squared, cosine squared times cosine times cosine is cosine squared. Power of suggestion. Sine squared x minus cosine squared x over sine squared cosine squared. And that's the whole purpose. That's not an answer. Your answer is the process. So the process on how to get there, that is going to be your answer. All right? So I just looked in the book, and the book took this side and simplified it. But honestly, guys, I'm here to tell you it doesn't matter. You can work both sides. You can see how one side is going to just work it the entire time to make it look like the other. It doesn't matter, all right? It's just however can you manipulate this and think through it in order to pull it off. All right, and we're just going to be doing a ton of these. So do it up. Now here's my suggestion to you. We've done only a few of them, so maybe we'll work through a couple more so you can see the thought process to get there. But the beauty of these videos is you can stop these. So if we want to verify this identity, you may realize that, hey, I'm going to try this on my own. Let me see how I can work this out. Okay, do that. That's great. Pause the video, work it on your own, and then come back and see how I did it if you get stuck with something. This would also be a good thing for us to work through like in our virtual office hours. All right, so let's do it. Honestly, this one is pretty much the same on both sides. So here's the kicker to this one, and here's what the thought process is. I have this one plus sign and this one minus sign, and then a cosine and a cosine. Well, the cosines are the same. But anytime you have this one plus or one minus, you need to be thinking about the conjugate there, right? Or the difference of squares or whatever you want to say. So I'm actually going to work this side, and I'm going to multiply by one minus sign over one minus sign. So that's a common technique that's used whenever you go through and you work these out, especially since it's already in terms of sine and cosine. The strategy is to put in terms of sine and cosine, because if you try to put in terms of something else, then that's where it gets funky. So I'm not going to touch this left side. For my right side, whenever I FOIL out this numerator, this minus this, shortcut that. Square the first term minus square the second term. That's the difference of squares. All over cosine times 1 minus sine. Now here's the other thing, and this is the thinker part, which is why these are so good. This numerator, 1 minus sine squared of x, doesn't look like an identity, but it is. But it is. Because if I have sine squared of x plus cosine squared of x equals 1, I can rewrite that and subtract sine squared from both sides. And whammo jabammo, it just happened. All right, so that's the other part of this. That's the other part of these problems, is looking back through this, and not only is it just straight manipulation and straight set up what it is, you have to be able to go through and manipulate. Now, here's the kicker. Anytime you have a 1 with either a sine squared or a cosine squared, you need to be thinking about some type of derivation that goes with the Pythagorean identity. All right? So that's your go-to method. Oh, well, is there some way I can manipulate this Pythagorean identity to pull this off? Oh, check it out. Yes, there was. So cosine x over 1 minus sine of x. And here's the other thing you're looking at. Ooh, check me out. I've got a 1 minus sine x and a 1 minus sine x here. I got this extra stinking cosine. So how can I work with it? That's the beauty of rewriting this over and over again. It keeps it fresh in your head of your goal of what you actually want to end up with. Then this cosine is the same thing as writing cosine of x squared. I don't know if we've talked about that or not actually. So cosine x squared is equivalent to cosine squared of x. When you square a trig, it's common, or any exponent for that matter, to put it between the trig function and the angle measure. All right, so goodness sakes, this cosine of x squared, one of these cosines now takes out one of those cosines because it's just a rational expression that you can simplify. And I get cosine x over 1 minus sine x. And now you end up with the same thing. Crazy, right? Yes, you're going to have to use algebra skills with your trig and your identities. So you have to use algebra manipulation in addition to algebra simplification of rational expressions. Algebra never, ever, 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 ever goes away. Ever. All right? Okay, let's do one more. I'm going to get a new page just so we have plenty of room. Verify the trig identity. Secant of alpha, which looks like a little fish kind of thing, it's alpha, plus tangent of alpha over secant of alpha minus tangent of alpha is equal to 1 plus 2 sine alpha plus sine squared alpha over cosine squared alpha. Now let me tell you some things I'm thinking about. So it's always good to sit back and assess. Number one, I know secant and tangents are buddies because of my Pythagorean identity. So that's the first thing I'm thinking about. How can I work with this to get some type of Pythagorean identity? Typically, you want to try to get rid of this denominator and make it a single term. Well, that makes sense because I've got a single term here. So on this side, when I'm looking through here, I'm going to do secant alpha plus tangent alpha, just because I want to make these to be perfect squares, right? That difference of squares situation. When you multiply the top and the bottom by the exact same thing, it's just like multiplying by a 1, and that's the beauty of it. Oops. So we'll multiply that out, okay? Over here, this is a perfect square trinomial. Do you see that? Typically the squared is in front, but this plus sign, and this 2 in the middle tells me that's a perfect square trinomial. So my next step, I'm going to put secant alpha plus tangent alpha squared, because I have the exact same thing that I am multiplying together, so I have two of those, over secant squared minus tangent squared. All right, so let's hang on to that here for just a second. This is 1 plus sine of alpha squared over cosine squared. All right. Because if I were to FOIL this out, square the first term, multiply these together by 2, and then square the last term, right? That's our pattern. Okay, now I've got this squared and this squared, so something's got to happen with that. That's looking like it's, so this is where I say look 2 steps ahead. What are some characteristics? Oh, this looks pretty good. This looks pretty good. Secant and tangent, when I have some squares, get to your toolbox. Get to your toolbox and start thinking. Pythagorean identity. 1 plus tangent squared x equals secant squared x. So look at what's happening. You see that? Sweet, right? Okay. So now I can replace this denominator with a 1. See, that's where those identities play such a huge role, you guys. So that denominator is now 1. So all I have is my numerator on this left side. And I'm going to switch that up to be in terms of sine and cosine. So now I have 1 over cosine alpha plus sine over cosine. It just happened. Do you see that? You guys, do you see this? This is where I'm saying look 2 steps ahead. What just happened right here? I now have cosine in the denominator. I have cosine in the denominator. I have 1 plus sine. I have 1 plus sine. Everything is squared. It just happened. So I now have 1 plus sine of alpha over cosine. This whole thing is squared. And honestly, I'm okay with you going straight to the answer at that stage. But I'm going to write out this extra step because I want to make sure that you can really see this algebra. When you have a rational expression, your exponent goes to both the numerator and the denominator. That's that basic algebra rules, all right? So I now have 1 plus sine alpha squared over cosine squared, 1 plus sine alpha, the quantity squared, over cosine squared. And there it happened. Just go through and practice. It's like, this is a lot like factoring to me, where how can I manipulate this? What are some key things that I look for? I'm looking for everything in my toolbox.